Hello everyone, welcome to my channel. Our today's topic of discussion is a very interesting and important part of trigonometry, that is the compound angle. Now, what is compound angle? It is the algebraic summation of two or more than two angles, and we use trigonometric identities to represent these angles. In today's video, I'll discuss about different formulae of compound angle as well as how those formulae will be applied for solving different problems will also be discussed in this video. So I hope this video is going to be very helpful for you. So please watch the video till the end. So let's begin the discussion with the formulae of this chapter. Suppose we are taking the angles A and B and we are making the algebraic sum between the angles. Now let's see how trigonometric identities are used in order to represent the summation of these two angles, that is A plus B. Suppose I am considering first sine of A plus B. Sine A plus B. What will it be? What will be the expanded form of it? It will be sine A into cos B plus cos A into sin B. Okay? If we take cosine of the sum of A and B, then it will be cos A into cos B minus sin A into sin B. If we take tangent of the summation, then it will be tan A plus tan B by 1 minus tan A into tan B. Right? So, considering the summation, algebraic summation of the angles A and B, we are getting sine of A plus B is sine A into cos B plus cos A into sin B. Cosine of A plus B equals to cos A into cos B minus sin A into sin B. And tangent of A plus B is equals to tan A plus tan B by 1 minus tan A into tan B. Now, if we get the subtraction of these angles, then what will be the representation? Sin A minus B. It will give sin A cos B minus cos A sin B. Okay. Now, if we take cosine of A minus B, it will give cos A cos B plus sin A sin B. And considering tangent of A minus B, we get tan A minus tan B by 1 plus tan A into tan B. Similarly, considering cot of A plus B, we get cot A into cot B minus 1 by cot B plus cot A and cot A minus B. That means A, which is considered, the angle A which is considered along anti-clockwise directions, that's why it is positive, and angle B is considered along clockwise direction, that's why it is negative. Now these two angles are added and hence we get cot A minus B, just like tan A minus B, sin A minus B, cos A minus B, etc. So in this case we get cot A minus B equals to cot A into cot B plus 1 by cot B minus cot A. Another set of very important formula of compound angle. Now, instead of two angles, if we consider three angles like angle A, angle B and angle C, and we find the summation of them and represent them through trigonometric identities, then what will be their format? Like I am taking sine of A plus B plus C at first, sine A plus B plus C. This will give you sine A cos B cos C plus sin B cos A cos C plus sin C cos A cos B minus sin A sin B sin C. So this is the formula of sin A plus B plus C, which is sin A into cos B into cos C plus sin B into cos A into cos C plus sin C into cos A into cos B minus sin A sin B sin C. Now considering cosine of A plus B plus C, we get cos A plus B plus C equal to cos A cos B cos C minus cos C sin A sin B minus cos B sin A sin C minus cos A sin B sin C. So this is the formula of cos A plus B plus C, that is cos A cos B cos C minus cos C sin A sin B minus cos B sin A sin C minus cos A sin B sin C. Now let's take tangent of A plus B plus C. This is equal to tan A plus tan B plus tan C minus tan A tan B tan C by 1 minus tan A tan B minus tan B tan C minus tan C tan A. Now these are the formulae of the chapter compound angle. In order to solve the problems of this chapter, all these formulae must be remembered. Let's take one problem. It's a very easy problem. Look, sin A here is given, that is 1 upon root 5. Cos B is 3 by root 10. And we have to show that A plus B equals to 45 degree. Okay. Here the values of sin A and cos B are given. And both the values are positive here. That means they are existing in the first quadrant. Now we have to show A plus B equals to 45 degree. So as the values are given in terms of trigonometric identity, so let's consider any trigonometric identity of A plus B. And according to the given information, we can see that it will be helpful for us if we consider either sine or cosine of A plus B, right? So let's solve it. I'm considering sine of A plus B. Now let's see, what do we find here? We know sine of A plus B means sine A cos B plus cos A sin B. Now look, the values of sin A is given and cos B is also given, right? So from this given two values, we can easily find out the value of cos A as well as of sin B, right? So let's find these values. Sin A, let's take it as number 1. Now look, sin A equals to 1 by root 5. So what is cos A? Yes, that is 1 minus sine square A, that is 1 minus 1 by 5. That is 4 by 5, that is 2 by root 5. Okay, so value of cos A is found. Now similarly, we can find the value of sin B also from this information. So cos B equals to 3 by root 10. So what is sin A? Sorry, sin B. This is obviously 1 minus cos square B. That is 1 minus 9 by 10. Now let's find out the value of root over 1 minus 9 by 10, which is equals to 1 by root 10. So the values of cos A and sin B are also found by us. So now let's use these values in expression number 1. So here we get sin A plus B equals to sin A means what? 1 by root 5. Cos B means what? 3 by root 10. Plus cos A means what? 2 by root 5. Into sin B means what? 1 by root 10. And here all the positive square roots are considered because the angles are in the first quadrant. So here we get 3 by root 50 means 5 root 2 plus 2 by root 50 means 5 root 2. So here we can see as the denominators are the same, so this is equals to 5 by 5 root 2, which will give us 1 by root 2. Now sin A plus B is equal to 1 by root 2, and we also know that sin 45 degree is 1 by root 2. So in this place we can write sin 45 degree. Isn't it, students? Now I hope you all have understood. As sin A plus B is equals to sin 45 degree, so comparing both sides we can write that A plus B is equal to 45 degree, and hence it is proved. So hope through this example I have made the concept clear that how the formulae, trigonometric compound angle formulae, can be used for solving the problem, the given problem. Now let's take another problem. Here we have to show that sin x minus y into cos x minus cos x minus y into sin x equals to minus sin y. That is, this left hand side of the equal sign is equal to right hand side of this equal sign, must be shown by us. So let's begin with the left hand side. So here we get in the left hand side sin x minus y into cos x minus cos x minus y into sin x. Now if we see the expression carefully, students, you will understand that it is resembling with the structure sin A cos B minus cos A sin B, isn't it? So what is the formula? It is the formula of sin A minus B, isn't it? Because we know sin A minus B is equals to sin A into cos B minus cos A into sin B. So here we get sin A minus B, and hence this is sin x minus y minus x. So all the x's are gone, so this is sin of minus y, and in my previous videos I have shown you that sin of minus theta is equals to minus sin theta. Why it is happening has been shown by in the video, in my previous video. So here we can write sin minus y equals to minus of sin y, and hence this is equals to the right hand side of the equal sign. So students, from this example, what we have seen? We have seen that we have to observe the problem first, and then we have to, after observing it carefully, we have to match it, or we have to select the formula, we have to match the expression with the given formula, given set of formula of the compound angle, and then we have to use that formula. Either we have to select the formula what can be applied for solving the given problem according to its given information. So observation is very vital for solving the problem properly, correctly. You must observe the problem carefully. Now let's consider another very interesting problem. Here it is given that show that tan 20 degree plus tan 23 degree plus tan 22 degree into tan 23 degree equals to 1. Here we have to show that tan 22 degree plus tan 23 degree plus tan 22 degree into tan 23 degree equals to 1. If we observe the problem carefully, we will find that only two measurements are given. One is 22 degree, another one is 23 degree, and summation of these two measurements will give us 45 degree. And we know all the trigonometric ratios of 45 degree. Now, which ratio, trigonometric ratio of 45 degree should be used here? Yes, tangent, tan of 45 degree, right? Because we have to prove the relation in terms of tangent. Okay, so let's begin with tan 45 degree. Here we get tan 45 degree is equal to tan, can be written as tan 22 degree plus 23 degree according to the given information. Okay, so now we know the value of tan 45 degree. This is equals to 1. And we also know the formula of tan A plus B. What is the formula? Yes, tan A plus tan B by 1 minus tan A into tan B. So let's use this. Tan A means tan 22 degree plus tan 23 degree by 1 minus tan 22 degree into tan 23 degree. Now let's do the cross multiplication. Here we get tan 22 degree plus tan 23 degree equals to 1 minus tan 22 degree into tan 23 degree. We have just made the cross multiplication. So obviously if this side is equal to this side, then obviously this one will be equals to this one. So here the presentation is done. Now look students, this can also be written as tan 22 degree plus tan 23 degree plus tan 22 degree into tan 23 degree. That means this expression is taken to the left hand side in order to get the structure, and this is equals to 1. So hence we have got the structure what we had to show. So again we have seen students, we have to first observe the problem. We have to first read the problem, and then we have to select that which identity, trigonometric identity must be used to solve the problem. And that identity will be chosen according to the given information. Let's take another example. Here, tan A equals to small m into tan B. It's an integer, right? Small m is an integer. We have to show that sine A minus B by sine A plus B equals to m minus 1 by m plus 1. Observe the structure carefully. We have to show sine A minus B by sine A plus B equals to m minus 1 by m plus 1. So from this expression, it is clear to us this relation, that is this tan A and tan B of this relation, must be represented as sine A by cos A and sine B by cos B. Because here we have to show sine A minus B by sine A plus B equals to m minus 1 by m plus 1. Okay, so let's do this. As it is given, tan A equals to m tan B. So tan A can be written as sine A by cos A equals to m into sine B by cos B. Okay. Now here look students, m is alone, that is m minus 1 by m plus 1. No trigonometric ratio is adjacent with m. So obviously from this given structure, we have to write sine A cos B by cos A sine B equals to m, that is by cross multiplication we have got this structure, right? So here only m is there, that means m by 1 is there. Now again look at the structure students, this is m minus 1 by m plus 1. So it is also clear to us, we have to now use the componendo dividendo rule, right, in order to get this structure. So using componendo dividendo, we get, what do we get? Sine A cos B cos A sin B by sin A cos B minus cos A sin B. And this is equals to m plus 1 by m minus 1. Okay. Now look at the expression. Here it is sin A cos B plus cos A sin B by sin A cos B minus cos A sin B. Right? Now the above portion will give us sin A plus B, isn't it? Just use that relation, use that identity. So here we get sin A plus B in the numerator, and now you think, pause the video and think, what does this denominator portion give us? Yes, it is giving us sin A minus B, right? Sin A minus B. And this is equals to m plus 1 by m minus 1. Now look at this structure, students. A minus B means sin A minus B is in the numerator, sin A plus B is in the denominator, and m minus 1 is in the numerator and m plus 1 is in the denominator. So let's just inverse this, both sides of the equal sign. So here we get sin A minus B by sin A plus B is equal to m minus 1 by m plus 1, and hence the given relation is found, and hence it is proved. So in this video we have seen that how the formulae of compound angles can be used for solving different trigonometric problems. You know, there are innumerable problems in this chapter. Now try to solve those problems. Till then, take care, stay safe, bye.